All right, so this is the fourth video for Unit 1. This is looking at the introduction to the research part. This is the second big part of this unit. It's actually Unit 2 in your textbook, but I clumped them all together. So the big ideas from this section is going to look at the goals for why research is conducted. It's going to talk about the importance of research and the impact of intuition, hindsight bias, and overconfidence. And it's going to talk about the steps to the scientific method. So, first, what are some goals for conducting research? Well, first, it hopes to describe behavior, it hopes to explain the environment, it also hopes to predict the future, and it hopes to control the environment as well. So, why do we need research? Well, if we didn't have research and the facts, a lot of times we would judge our guesses off of our gut instinct. And with our gut instinct, research is important because we often think about a situation, we go with our gut instinct. And a lot of the times it's not true. So we think we would answer it and we would go with this gut. But when we do that, the deep within us, this instinct, the awareness of the internal guide, is not always the right way to go. Our gut instinct is often not true, it's just a personal belief. So we believe maybe we would do something one way, but then when we actually have the research, that's not the way you would essentially answer a question. Intuition can impact overconfidence and hindsight bias. Hindsight bias is the idea that you knew it all along phenomena. It's the tendency to believe after learning the outcome. So, after the Cubs won the World Series, you may have stated something like, "Oh, I knew they were going to win." But for many years, they didn't win. Or after somebody maybe breaks up with you, your friends turn to you and say, "I knew he was bad all along." Well, if they knew he was bad all along, why did they let you date him? After September 11th, the second tower was not cleared right away after the first one was hit. They didn't know that it was a terrorist attack. So many people question, why didn't they clear the second tower? They knew it was going to happen all along. Another reason why we need research is because oftentimes we're overconfident. Overconfident is a tendency to be overconfident in your abilities, the tendency to be more confident than correct, to overestimate the accuracy of our beliefs and our judgments. We need science to help gather and sift through evidence that restrains our intuition. Oftentimes, many students don't study because they think they know the information. This can skew their data and they be because they're overconfident. What does a researcher need? What is the scientific attitude that they need? Well, researchers need to be curious. They need to have a passion to explore. They need to have skepticism, which is a willingness to question any truth and ask evidence. And they also need to have humility, the awareness to our own error and the openness to a new perspective. So, thinking about a researcher, these are some key traits they need to have. How is research now organized? Research is organized through the scientific method, and you've probably learned this in your science class. The 5 steps of the scientific method is observe and ask questions, think critically, develop a hypothesis, test your hypothesis using the methods of surveys, experiments, case studies, correlations, and observations. Then you need to, once you get all the data, you need to crunch your data and analyze it. And lastly, you need to either share it or you need to modify it and redo it if your hypothesis is wrong. So let's first talk about critical thinking. Critical thinking is the thinking that does not blindly accept arguments and conclusions. Rather, it examines assumptions, discerns hidden values, evaluates evidence, and assesses conclusions. It looks and evaluates all data. So you're thinking deeply about an issue, not judging it based off of a bias, etc. Once you think critically about a topic, you then develop the hypothesis. This is often known as the little theory. It's a specific statement that attempts to explain how variables are related. Smoking and lung cancer. It's a testable prediction. It's often implied by a theory. It attempts to explain how things are related. It is not true. You are then going to gather data, to hopefully prove it to be true. When you're organizing it and you're developing your hypothesis, you need to have an operational definition. An operational definition is a precise set of procedures for research. It's the specific description of the procedures and steps needed to define research variables and the experiment. You want to make sure you can replicate the experiment over and over and over again. So the procedure must be repeatable. This is why you need a concrete operational definition. If I said, I want to know if school makes children happy, what is happy? Does that mean they laugh 5 times? It needs to be able to be measured. Third thing then is once you have your hypothesis is you collect the data. And we're going to go over this in the next video, the methods of research. How can you collect data? You could do a case study. You could use a survey. You could do an observation. You could do a correlation. Or you could set up an experiment. And an experiment is the only one that proves cause. So once you get all your data back, whether it's from, you want to make sure that it's valid, and you also want to make sure it's reliable. So, is it valid? The extent to which the operational definition measures what it's supposed to. Does it cover the material it's supposed to? So, if you wanted to understand if students understood a question about the key figures, did you ask them questions on the key figures? Or was the test measuring something else? Is it reliable? Do you get similar results back from the individuals time and time again? Once you then have that data from the surveys, from the experiment, you want to analyze the results. This step consists of looking at the data, collecting, and seeing if it supports or disproves your hypothesis. Oftentimes, this is the part where statistics is incorporated. You need to understand how to calculate the mean, median, and mode, which we'll talk about later in this chapter. And then once the data you have can either be quantitative or qualitative. Quantitative data describes results in numbers, graphs, and presents information in statistics and charts. Qualitative data is presented in verbal terms. So you could either get data based off of how many students were able, the percentage of something, or you might get data about the qualities of the individual. Once then the data is found and analyzed, researchers can either publish, criticize the information, or replicate the results. This is when oftentimes you share your research experiment with individuals. Critics check others by replicating the study. It's done over and over again. A theory may be developed, or if your hypothesis wasn't proving to be true, research experiments can be done over. So, this video talked about the goals of research. It also talked about the importance of research with intuition, hindsight bias, and overconfidence. And then it finally gave you the 5 steps of the scientific method, which was critical thinking, developing a hypothesis, gathering your data, analyzing your data, and then publishing it.